I/O. Okay, in previous chapters, you've learned how to use the built-in input function to accept standard input from the keyboard. You've also learned how to send data to standard output, the screen, using the print function. While understanding and utilizing standard input and output will work well for certain types of applications, you will often need a place to store the data generated by your program. Also, you will need a way to retrieve saved data as well. One of the most common places to store data is within a file. You can read input and write output to a file, just like you can read input from a keyboard and display output on the screen. To open a file, use the built-in open function. The pattern for this is open and path to the file. The path to file can be either an absolute or a relative path, and it includes the file name. An absolute path will contain the entire path beginning at the root of the file system, be that a slash in Mac or Linux or a drive letter in Windows. Examples of absolute paths are, in Linux, if we have slash, that's the root, and var is a folder, and log is a folder in the var folder, and the messages is the file we want to read or write. And in Windows, if we have C:\\, log, then log is a folder in the C drive, messages is a folder in the log folder, and then data.txt is a file in the messages folder. A relative path, however, will comprise just the file name or a portion of the path which starts at the current working directory. An example of a relative path is log/messages, and see that there's no slash in front of log. This example supposes the current working directory is /var if we're looking for this file in the var log folder. So if our current working directory, where the application is running from, is in /var, then we can just say log/messages to access the file messages in the log folder, which is in the var folder. Note that while Unix or Unix-like operating systems make use of forward slashes as a directory separator, and the Windows operating system uses backslashes as the directory separator, Python recognizes forward slashes even when running on the Windows operating system. For example, C:\users/David/documents/python-notes.txt is a valid absolute path within Python, and documents/python-notes.txt is a valid relative path. So even if in Windows we use backslashes, in Python you can use forward slashes as if they were backslashes. The open function will return a file object, which is sometimes referred to as a stream object. Okay, just like we call a string of characters a string, characters going to or from a file are a stream object. So this can be used to perform operations on the file passed to the open function. To read the entire file in at once, use the read method on the file object. The read method returns a string comprising the file's contents. The following code listing is an example. Okay, so we've got a variable hosts, and we say that's equal to open, and this is an absolute path to the hosts file in the etc folder. Then we can say host file contents equals hosts.read. So that will read the contents of this file into this string variable. If we then say print hosts file contents, it will show us everything that's in that file. Now, just as an aside, this happens to be a file that's on most computers. It has to do with networking. We won't go into exactly what it is, but this is a text file that happens to exist on most computers. If it's Mac or Linux, it is in the etc folder, in the root directory of the drive. Okay, in order to modify this example to work on a Windows system, We set the hosts variable to c:/windows/system32/drivers/etc/hosts. Okay, so the hosts file on Windows is in this folder. And again, in Python, we're using forward slashes, even though in Windows we would use backslashes. So hosts equals open and this path to that file. Let's just take a look at that file. I'm using Windows. So if I open up File Explorer, I'm in a folder which is c:/users/Dave/documents/courses/Python license succinctly code chapter 8. Okay, so that's the folder that I'm currently in. I want to look for this file hosts. It's in drive C, so we can find it here, and was under Windows, System32, drivers, etc. And there we see the file hosts. So the folder here is c:/windows system32 drivers etc. These are some files used for networking. We're not covering that in this course, but these files exist. Hosts is a text file, and if I open it up, I'll see that this is what's in the hosts file. Okay, there's quite a bit more text in here than there is in the example. But you will see that we see this 1.127.0.0.1 localhost. And note here I'm showing that each line ends with a carriage return and line feed. I can turn this off so it doesn't show these symbols. So it just looks like plain text now. So that's the file that we're reading from. This file contains a lot more, so in the example it would have read and displayed all of this text. File position. Whenever a file is read, Python will keep track of your current position within that file. In cases where the read method returns the entire file, the current position will always be at the end of the file. If you were to call read again, an empty string would be returned since there is no more data to return at your current position in the file. To change the current file position, use the seek method and pass in a byte offset. For instance, to go back to the beginning of the file, use seek 0. If, however, you are looking to start at the 5th byte of the file, use seek 5. Take note that in many cases the nth byte will correspond to the nth character in the file. However, in some cases it will not, so be aware of that. For UTF-8 encoded files, you will often come across characters that are longer than 1 byte. You will encounter this situation when using Kanji, Korean, or Chinese. In order to determine your current position in the file, use the tell method. So if we say host is equal to open, and we're opening the hosts file again, then we print the current position and we use hosts tell. We haven't read from it yet, so this we would expect to be 0. And we print hosts read. That will now read the entire contents of the file. So now if we print hosts tell, this will return us the current position, which is the last character in the file. If we print hosts read again, this will be an empty string because we're at the end of the file. The position is the end of the file. If we now say hosts seek 0, we're moving the position back to the beginning. If we print hosts tell, this should show us the position is 0. And if we print hosts read, it should show us the entire contents of the file again, because now it's reading from the beginning. Okay, so here we see output is current position 0, then it shows the entire contents, and the next time we run tell, it will show us 20 because there's 20 characters in the file. And then we did a seek 0, so then the current position is 0, and then we did a read, and it shows us the entire contents of the file again. The read method will accept the number of bytes characters to read. The following example demonstrates reading the first 3 characters of the host's file. In this case, the first 3 characters corresponds with the first 3 bytes. So here again, we open the host's file, then we print hosts.read3. So that will print the first 3 bytes, which happens to be the first 3 characters. And that would be 127. And then if we print hosts tell, it shows us the position, and the position will be 3. Closing a file. It is always a best practice to completely close a file once you are finished with it. Keep in mind that if your Python application opens too many files during its execution, you could be faced with a too many open files error. To close a file, simply use the close method on the file object. So again, we create the file object, hosts is equal to, open the hosts file. Host file contents is hosts.read, so that's the contents of the file in this variable. If we print host file contents, we get the contents of the file. And we end with hosts.close, that closes the file. So what we're saying here is that you should always close a file once you're finished using it. Note that each file object has a closed attribute that returns true if the file is closed and false if it is not. You can make use of this attribute to ensure that a file is indeed closed. So here, hosts, we create a file object, host file contents, we read the contents into this variable, then we print hosts.closed. Okay, so this will be false because the file is still open. So we can now say if not hosts.closed, hosts close. So if it is not closed, if this is false, then we close the file. And so now when we print hosts.closed, this should be true. Okay, so the first time this returns false, the second time this returns true. Okay, automatically closing a file. To automatically close a file, use the with statement. The pattern is with open file path as file object variable name, followed directly by a code block. Whenever the code block finishes, Python will automatically close the file. Also, in cases where the code block is interrupted for any reason, including an exception, the file will be closed. Okay, so here we say print start reading a file with open the file path as hosts. Okay, so this is going to set hosts equal to this file stream. The with statement then lets us have a block of code where we can do things, where we can print if hosts is closed, and we can print hosts read, and now we print finish reading the file and file closed, hosts closed. This should be true now, because after we exit this block of code, then the file is automatically closed. So the with statement lets you create a file object, operate on the file object, and then it closes that file automatically when you exit this code block. Okay, so the output was start reading the file closed is false, it prints the contents of the file, and then we finish reading the file, and is the file closed? True. Reading a file one line at a time. To read a file one line at a time, use a for loop. The pattern is for line variable in file object variable, directly followed by a code block. So here we've got with the open file as the file. So this is now our stream object. Then we've got a for block inside the with block for line in the file. So line is now going to be one line in the file. We print line. Okay, and because this is a for loop, if there's another line in the file, it will then print the next line. And it will keep on doing this until it reaches the end of the file. Okay, so the output of this is the first line of the file, here's the second line of the file, finally this is the third and last line. Okay, note that the file contents was like this. So we created a file previously with this contents. This is the first line of the file, here's the second line, and finally this is the third and last line. The output will contain a blank line between each one of the lines in the file. This is because the line variable encompasses the complete line from the file, which includes a carriage return or new line character. To remove any trailing white space, including the new line and carriage return characters, use the rstrip string method. Okay, so here we're using a with block. We open file.txt as the file. Then we have a for loop for line in the file and print line rstrip. So it's going to take each line and it's going to strip off the carriage returns or new line characters. So the output is going to be, this is the first line of the file, here's the second line, finally this is the third line, and you notice there's no spaces between the files, but between the lines. Let's just take a look at that file. So I'm back in File Explorer, I'm back in my folder here, and inside this folder I've got a file named file.txt. If we take a look at this file, I'll open it up in a text editor. Okay, so this is now the contents of the file. It's got 3 lines, and each line ends with a carriage return and a line feed. And this editor lets us take a look at those, lets us see those by saying show symbol, show all characters. So we'll see that this line ends with a carriage return and line feed, and it also has a space at the end. The second line also has a space and then a carriage return and a line feed. And then the last line has just carriage return and a line feed. Okay, file modes. Whenever you open a file, you have the option of specifying a mode. The pattern is open, path to file, comma, mode. So far, we have been relying on the default file mode of R, which opens a file in read-only mode. If you want to write to a file, clearing any of its current contents, use the W or write mode. If you want to create a new file and write to it, use the X mode to create a file. In cases where the file already exists, an exception will be raised. Using the X mode will prevent you from accidentally overwriting existing files. If you're looking to keep the contents of an existing file and append or add additional data to it, use the A mode, that's to append. With both the W and A modes, if the file does not already exist, it will be created. If you want to read and write to the same file, use the plus mode. Okay, so summary, R is for reading, and that's the default, so you don't have to specify R if all you want to do is to read from a file. W is to open for writing, and it will overwrite an existing file if the file already exists. X creates a new file and opens it for writing, and if the file exists, this will throw an error. Okay, so it doesn't allow you to accidentally overwrite a file. A is to open for writing appending to the end of the file if it exists. Okay, so if the file exists and you open it with A, whatever you write to the file will appear at the end of the file. B is for binary mode. Okay, so far we're talking about text files. And text files, you put in normal character strings. Binary mode is for binary files, and that would be files like video or audio or something else where you're putting pure binary into the file. The T is text mode, and that's the default. And plus opens a disk file for updating, reading and writing. Keep in mind that you can also specify if the file you are working with is a text file or a binary file. By default, all files are opened as text files unless you directly specify otherwise. Simply append a T or B to one of the read or write modes. For example, to open a file for reading in binary mode, use RB. To append to a binary file, use AB. Also keep in mind that while text files contain strings, binary files contain a series of bytes. Put simply, text files are readable by humans, while binary files are not. Example of binary files include images, videos, and compressed files. To look into the current mode of a file, examine the mode attribute on a file object. So with open file as the file, print the file mode. Okay, so since we didn't specify a mode here, it will be in read mode. So if we print the file.mode, it will output an R. Okay, writing to a file. Now that you are familiar with the different file modes, let's try writing some data to a file. This is as simple as calling the write method on the file object and then supplying the text you wish to write to that file. So with open file text, and now we specify the W mode as the file. The file write, this text will be written to the file, and then the file write, here's some more text. Now with open, okay, and because we're outside of the with block, it closes that file. So now with open, we're opening the same file, but we don't specify the mode, so this is now read mode. And again, it's as the file. If we print the file read, it will print the contents of the file. So the output will be, this text will be written to the file. Here is some more text. And notice that it's all in one string. It's not in two separate lines. Keep in mind, however, that the output you receive may not be exactly what you expected. The write method will write exactly what was supplied to the file. If in the previous example, no carriage return or line feed was provided. As a result, all the text ended up on the same line. The \R sequence represents the carriage return character, and the \N represents a new line. Let's work through the examples again, but this time let's ensure that we are using a new line character at the end of the line. So here again, with open file 2.txt for write as the file. Now we write, this text will be written to the file with a \N at the end of this string. So that's a new line character. And then the file write, here is some more text with a \N. Then in our next with block, we open this for read, and we print the file read, and the output will be, this text will be written to the file, and then on the next line, here's some more text, because we specified new lines at the end of each of these strings. Keep in mind that the Unix-style line endings will only contain the new line character. Mac and Linux files use this type of line ending. Windows-style line endings can be formed using \R, \N. That's the carriage return character followed by the new line character. In Windows, it has been standard to end lines with carriage return line feed. But these days, new line is acceptable because it's very common in Linux systems to only end with a new line character. Binary files. The key thing to remember when you are dealing with binary files is that you are working with bytes, not characters. The read method will always accept bytes as an argument when dealing with binary files. Remember that the read method will accept characters whenever the file is opened as a text file. Okay, so in this case, we have a with open. We're opening a file called pig.jpg, And notice that this is now a relative path. It doesn't show subfolders. So this file needs to be in the same directory as the application. And it's being opened as a read-only binary file. So the file is opened as pig picture. So when we say seek to, it moves to the second byte. We then read 4 bytes. If we print pig picture tell, it will show that we're at byte number 6 now. And if we show the mode, it shows that it's read-only binary. But what it read here is not text, it's binary. Okay, this is a JPEG file. It's a type of image file, so it's stored in binary. So let's take a look at this binary file. I'm on a Windows computer. I've got the File Explorer open. I'm looking in this folder. The folder is C:\users, Dave, documents, courses, Python succinctly, code, chapter 8. And in this folder, I've got these files, chapter8.py, file.txt, and pig.jpg. Now, in Windows, if you double-click on a file, if it understands the extension, it will open it in a default program. So this is a JPEG file. It's a picture. If I open it, it will open in a picture viewer. And so in this case, it's a picture of a pig. If we open it as though it's a text file, I can try opening it with a text editor. And it will look like garbage. It's all these funny characters, and the reason is because it's a binary file. It's interpreting the bytes as characters, but they don't mean anything because it's not a text file. Exceptions. Whenever you are working with anything that exists outside of your program, you greatly increase the chance of errors and exceptions. Working with files falls squarely into that category. An example of this may occur when a file you are attempting to write to may be read-only, or a file you are attempting to read from may not be available. In a previous chapter, we briefly examined the try except block. In the following example, we'll see how it can be put to use. Okay, so here we've got a program, comment, open a file, and assign its contents to a variable. If the file is unavailable, create an empty variable. So we start our try exception block. So we say try, say context equals, and we open context.txt, and we read it. If this fails for any reason, that throws an exception, and that will set context equal to an empty list. We then print the length of contexts. So if the file exists and contains a list of 3 strings, the output is going to be 3. If the file does not exist, the output is 0. Okay, review. Use the built-in open function to open a file. The pattern is open and a path to the file and mode. If mode is not supplied when opening a file, it will default to read only. Okay, so you can leave the comma and mode out if you just want to read the file. Forward slashes can be used as directory separators even when you are using Windows. Using the read file object method will return the entire contents of the file as a string. Use the close file object method to close the file, and you should always close the file when you're finished with it. Use the with statement to automatically close the file. The pattern is with open file path as file object variable name. That directly followed by a code block. Use a for loop to read a file 1 line at a time. The pattern is for line variable in file object variable. use the rstrip string method to remove any trailing white space. So that will remove carriage returns and line feeds and spaces from the end of each line. Write data to a file using the write file object method. The read file object method accepts the number of bytes to read when a file is opened in binary mode. When a file is opened in text mode, which is the default, read will accept characters. In the majority of cases, a character will be 1 byte in length, but keep in mind that this does not hold true in every situation. Okay, in different languages, some characters are shown with 2 bytes instead of 1 byte. Always plan for exceptions when you are working with text files. Use try except blocks. Okay, you never know if there's an issue with a file, maybe the file doesn't exist, or maybe it exists when you're trying to create it, and so on. So always use try except blocks. Okay, exercises. We'll do 2 exercises. Line numbers. Try creating a program that opens file.txt, read each line of the file, and then prepend it with a line number. Sample output. Okay, so the file contains these 3 strings, but it doesn't contain the numbers. So we want to read a line from the file, and then we want to print the line number. So the first line is 1, a colon, a space, and then the line. Then it should read the next line and show the line number, colon, space, and the next line, and so on, for however many lines it has. Okay, we'll skip over the solution. You can pause to look at the solution after you've tried it. And exercise 2, alphabetize. Try reading the contents of animals.txt, and from there create a file named animals_sorted.txt that is sorted alphabetically. The following code listing is the body of the animals.txt file. So we create a text file with a list of animal names. Each line ends with a new line character or carriage return and a line feed. And the names of animals are not in alphabetical order. You need to sort it so that it is in order. And again, we'll skip over the solution. And that's the end of chapter 8, file I/O. The next chapter is chapter 9, modules, and that will also be the last chapter in the course. So I'll see you then.